Non-homogeneous partial differential equation with a variable coefficients a x square dou square z by dou x square, b xy dou z by dou x dou y, plus c y square dou square z by dou y square. X square, xy, y square, these are variable coefficients equal to function of xy. This is called variable coefficients of PDE. Let us consider a square of dou square du by dou x square. Here u equal to log x. Let u equal to log x. Dou u by dou x equal to 1 by x. Dou u by dou z by dou x equal to dou z by dou u by dou x. U is multiplying, dividing. Dou z by dou u of 1 by x. We are changing instead of x, u instead of x. X cross x dou z by dou x equal to dou z by dou u. The PDE with variable coefficient may be like this: dou square u by dou x square plus b xy dou square z by dou x dou y plus c y square dou square z by dou y square, sometimes d z x dou z by dou x, e y dou z by dou y. Single derivative also would come in the sums f of x y. See, for this x dou z by dou x, where a, b, c, d, e are constants, x dou z by dou x is dou z by dou u. Again, consider like this: x dou z by dou x equal to dou z by dou u. First, we should consider d equal to dou by dou u, d dash equal to dou by dou v, d z equal to dou z by dou u, d dash z equal to dou z by dou v. Again considering x dou z by dou x equal to dou z by dou u. Differentiating with respect to x. Again, u to v form x dou square z by dou x square. Now, this is differentiate with respect to x is 1 dou z by dou x. U to v form. First, keep this untouched. Differentiated plus this is untouched, x is differentiated 1 equal to dou by dou x of dou z by dou u. Carefully follow. We are differentiating with respect to x only. Here, this also dou by dou x. With respect to x only, we are differentiating. X dou square z by dou x square plus dou z by dou x equal to dou by dou u of dou z by dou u by dou x. Here, multiplying dividing by dou u. Right side, dou square z by dou u square. This is dou square dou u square. Dou u by dou x is 1 by x. Multiplying x on both sides, x square dou square z by dou x square plus x dou z by dou x equal to dou square z by dou u square. Again, x square dou square u by dou x square plus x dou by dou x is x dou u dou z by dou x equal to dou square z by dou x square. X square dou square u by dou x square plus dou z by dou u. Already we know x dou x is dou z by dou u equal to this is dou square z by u square. Dou u square. This taking that side. X square dou square z by dou square z by dou x square equal to dou square z by dou u square minus dou z by dou u equal to x square dou square z by dou x square equal to d square minus d into d minus 1 of z. This is important when doing all these variable coefficient sums. Again, we are going to consider about the second derivative x and y. Dou u by dou x equal to 1 by x. Dou z by dou x equal to dou z by dou u by dou x. Just we have seen dou z by dou u. What is dou u by dou x? 1 by x. Cross x, dou z by dou x equal to dou z by dou u. Just we have seen the previous steps. Again, differentiate with respect to y. Differentiating with respect to y. What? That y means x is a constant. Dou square z by dou y dou x. Dou by dou y of dou z by dou u. Dou by dou v of dou z by dou u of dou v by dou y. Take v also log y dou v by dou y equal to 1 by y. Here I am writing x dou square z by dou x dou. We can write in order dou x dou y, dou x dou y equal to dou square z by dou v dou u into 1 by y. This 1 by y. Cross this. Xy dou square z by dou x dou y equal to dou square z by dou u dou v. This is also important step. We are going to apply for this. Again, similarly, we can do for y also, for second derivative for y also. Again, overall, I am going to write x dou e by dou x equal to dou z by dou x equal to dou z by dou u s square, which is d. S square dou square z by dou x square equal to d square minus d dash. D square minus, just we have d square minus d. D take out d minus 1. Similarly, xy dou square z by dou x dou y equal to d dash. D dash because this is dou square z by dou u dou v, which is d dash. We know already from the homogeneous. Similarly, y dou z by dou y equal to d dash y square dou square z by dou y square equal to d dash minus 1. You can write either also. You can write either also. Is that? Is that? Therefore, x square, you can write z at the side. Let us do sums by applying these steps. Sum number 1. S square dou square z by dou x square plus 2xy dou square z by dou x dou y plus y square dou square z by dou y square equal to 0. Here u equal to log x, v equal to log y, x dou z by dou x equal to dou u by dou z by dou u, which is d. S square dou square z by dou x square equal to d square d into d minus, just we have seen already. Similarly, y dou z by dou y equal to dou z by dou v d dash y square dou square z by dou y square equal to d dash minus 1. Again, xy dou square z by dou x dou y equal to d into d dash. This are applying in the sum. Already we have done this proof for this. X square d minus 1 to d dash plus d dash minus 1 of z equal to 0. D square minus d plus 2 d dash square plus d dash square minus d dash of z equal to 0. D square plus 2dd dash plus d dash square minus d dash of z equal to 0. Here d plus d dash whole square, a plus b whole square, a square plus 2ab plus b square. Take 1, take a d, 90 take out, d plus d dash of z equal to 0. D plus d dash taking out, d plus d dash minus 1 of z equal to 0. There are two factors, d plus d dash minus 1. D plus d dash into d plus d dash minus 1 of z equal to 0. Taking the first factor, d plus d dash, here d minus md dash minus c equal to 0. Here XOS UV, CF1 equal to, here d plus d dash minus 0 equal to 0. Comparing this, m equal to minus 1, c equal to 0. See, CF1 equal to e power cu. Instead of x and y, we are using u and v. Phi 1 of v plus mu y plus mx, v plus mu, e power c0, 0, phi 1 of v, m is minus 1, minus u. Therefore, phi 1 of v minus u. CF1 is phi 1 of v minus u. Similarly, we are finding CF for the second factor also. Taking the second factor, d plus d dash minus 1 equal to 0. D minus md dash minus c equal to 0. Compare the coefficients. M equal to minus 1, c equal to 1. What is CF2? E power cu phi 2 of v minus v plus mu y plus mx. CF2 equal to e power c is 1 u phi 2 of v minus u. CF2 equal to e power u phi 2 of v minus u. Writing the answer, general solution. General solution z equal to CF plus PI. Z equal to CF is CF1 plus CF2, not PI here, no function at the right side. Phi 1 of v minus u plus e power u phi 2 of v minus u. We know u equal to log x, e power u equal to x. See, there is a step e power u, log of e power u equal to u. Let us do for x. Log of e power x equal to e power log x equal to x. Then separate here. Log of u equal to log of e power u equal to e power log of x, which is x. Here u equal to log x. Z equal to 5/1/2. V is log y. Log y minus log x plus e power eu equal to x. 5/12. Log y minus log x. Z equal to 5/1/2. Log of y by x. Log y minus log x. Log y by x plus x. 5/12. Log y by x is the answer. Sum number 2. Solve y square dou square z by dou y square minus y dou z by dou y equal to x y square. We know already u equal to log x, v equal to log y, x dou e by dou x equal to dou z by dou x equal to d s square dou square z by dou s square. I am not writing z here, this will confuse you. Equal to d into d minus 1. Similarly, y dou z by dou y equal to d dash y square dou square z by dou y square equal to d dash minus 1. Applying this in the sum, y square dou square equal to d dash minus 1. Y dou by dou is d dash of z equal to x. Here x equal to e power u, y equal to e power v. Right side x equal to e power u, y equal to e power v whole square. D square minus d dash of z equal to e power u, u power 2v. D square minus 2d dash d dash square minus d dash square minus 2d dash of z equal to e power u plus 2v. Taking d out, d dash out, d dash minus 2z equal to e power u plus 2v. I am writing again d dash minus 2 of z equal to e power u plus 2v. There are two factors here, d dash minus 2. D dash equal to 0. We know already d dash minus md minus c equal to 0. Here CF equal to, here m equal to, consider this formula for this, m CF1 equal to e power d dash comes front side, CV 5/1/2 u plus mv, just changing because d dash comes at the front. CF1 equal to, here comparing these, compare these two, d dash minus CD minus c equal to 0, d dash minus md minus c minus 0 minus md here 0 minus c equal to 0. Compare the coefficient m equal to 0, c equal to 0. Therefore, CF1 equal to e power c is 0 here. 0, 5 1 half, changing u plus 0v equal to 5 1 half u is a CF1. CF1 is 5 1 half u. Again, taking the second factor, d dash minus 2 equal to 0. D dash minus md minus 2 equal to 0 minus c equal to 0. D dash minus 0d minus 2 equal to 0. M equal to 0, c equal to 2. CF2 equal to e power d dash comes front side. Therefore, CV 5 2 of u plus mv, already y plus mu mx here instead of changing because d dash comes at the front equal to CF2 equal to e power c is 2 e power 2v 5 2 of u plus 0. Therefore, u power 2v 5 2 of u. CF2 equal to e power 2v 5 2 of u. PI, again taking PI, particular integral e power u plus 2v divided by d dash minus 2 e power u plus u plus 2v d dash. Write the coefficient of v to d dash e power u plus 2v divided by 2 d dash minus 2. Again, put coefficient of v for the d dash. See, we have c in the sum as reverse order. D dash first minus md minus c equal to 0. We have seen the sum in reverse order. Therefore, if you remove this factor, we have to integrate with respect to v only. Therefore, u plus 2v by 2 when remove is what? dv, which is v. We have to write v only, integrate with respect to v only. If it makes 0, therefore v e power u plus 2v divided by 2. General solution. General solution. Z equal to CF plus CF1 CF2 plus PI. CF1 is 5 1 half u plus e power 2v 5 2 half u plus PI is v e power u plus 2v by 2. Coming to the reverse order, u equal to log x, v equal to log y equal to 5 1 half log x e power 2 log y 5 2 half log x plus v is log y e power log x plus 2 log y by 2 equal to 5 1 half log x plus e power log y square equal to y square phi 2 of log x plus log y e power log of, I am writing from the above, from the beginning, from the top. Phi 1 is space is not available. Phi 1 is log x plus e power log y square. 2, the log rule is 2 comes up. N log n equal to log of m power n is the rule. We applied the 2 comes as power. Phi 2 log x plus log y e power log x plus 2s comes to power log of y square by 2 equal to phi 1 of log x y square. E log vanishes. E log x equal to x. We know already. Therefore, y square comes. Phi 2 log x plus log of log y equal to e power log x y square by 2. Phi 1 of log x plus y square phi 2 of log x plus log. Similarly, same e log vanishes. X y square by 2. Therefore, phi 1 of log x y square phi 2 of log x plus log y x y square log y, right? X y square log y by 2 is the answer.